Hello, everyone. Welcome back. Today, we're going to be talking about vertical and horizontal asymptotes. So, we already know some things about them from advanced functions, which we'll review, and there's also more to learn about these asymptotes as well that we can learn or that we can interpret from a calculus perspective. So, let's start with vertical asymptotes. Vertical asymptotes at x equals to a of a function occur when the denominator of the function is 0. If the numerator of the function and the denominator are at 0 of x equals a, then the function has a hole. So in other words, let's translate that to English terms. If we have something like this, that means that we have a vertical asymptote at x equals to a, right? Because we have a 0 in our denominator when x equals a in that situation. But let's say that we have 3x plus 4 and then x minus a over x minus a. In this case, we have this in our numerator and our denominator, so these cancel. So this just makes a whole at x equals a. So that's the clarification. Basically, if we're able to cancel out our x minus a with the top, then that means that it's a whole. Otherwise, it's an asymptote because that function occurs when x equals a gives the function a denominator of 0. And I want to be clear, x equals a is just it's just a general case. It doesn't have to be a, right? It could be x minus 3, like that. Then we have an asymptote at x equals 3. Or it could be 3x plus 2 over x plus 2, right? Here these cancel, and we have a whole at x equals to negative 2, and so on, right? So I hope that kind of clears it up as to when something's a whole versus when something is a vertical asymptote. It also says to determine the behavior of the function at x equals a, we need to find the limit at x equals a. We need to find the limit from the right and the limit from the left, right? We need to find out, are those limits the same, right? If we find the right hand limit and the left hand limit, we have found the overall limit and we know whether or not there is one. And we just understand what is the behavior at x equals a, right? And keep in mind too here that in these situations, assuming that x equals a is a vertical asymptote, which is what they're implying here, we have a vertical asymptote like this, then that means that the right hand limit and left hand limit are most likely going to be infinity or negative infinity. Sometimes there might actually only be a right hand limit or left hand limit on one of the sides. That's also possible. Sometimes they might be going the same direction. Maybe they're both going to infinity. Maybe they're both going to negative infinity. Maybe one's going one way, one's going the other, right? But generally speaking, if we're assuming that x equals a is the vertical asymptote, then that tells us that. Now, however, let's say x equals a is just a whole. Well, then the right hand limit and the left hand limit would be the same in that case. So the overall limit exists, and that would mean that the limit would be where the whole is, right? So in that situation, it wouldn't be infinite. So it just depends on the situation. Are we looking at a whole or are we looking at the vertical asymptote? Depending what we've determined that is. Okay, let's move on to horizontal asymptotes. The graph f of x equals to h of x over g of x has a horizontal asymptote at y equals 0 if the degree of the denominator is higher than the degree of the numerator. Okay, so basically that's our first rule. If the degree of the denominator is higher, then we have a vertical asymptote, a horizontal asymptote at y is 0. Now let's say the coefficient of the highest degree term in the numerator over the coefficient of the highest degree term in the denominator if the degree of the numerator is the same as the degree of the denominator. So let's translate that to English. Let's do an example here. Let's say we have 3x to the 4 over 4x to the 4, and then plus a bunch of other stuff that has lower degrees. So maybe we have an x squared in there on either or both, or x cubed, or x, or just constants, whatever it might be. Then in here, the asymptote is equal to 3 over 4, right? It's just going to be the coefficients of the highest degree term if the degree is the same. Okay, whereas this one up here, where we had it to be y equals 0, this occurs when? This occurs when we have something like this, right? Something where the degree of the denominator is greater, 1 over x squared, or 1 over x, or x to the 4 over x to the 6, right? Things like that. We would have a horizontal asymptote at y equals 0 because degree of the denominator is larger. Now, what if the degree of the numerator is larger? If the degree of the numerator is higher than the degree of the denominator, that means there is no horizontal asymptote. And sometimes this is the case. Sometimes there will be no horizontal asymptote, and also sometimes there will be no vertical asymptote, right? Some functions don't have asymptotes at all, right? So that is possible. So it's important to check for both of these, for which one of these three cases it is, to determine the asymptote. Now, keep in mind, these things are mutually exclusive. Now, what do I mean by that? I mean that only one of them can be true. Either the degree of the denominator is higher, or the degree of the numerator is higher, or they're both the same degree. And so there can only ever be one horizontal asymptote in these general cases. Now, there are other ways that we could have more than one. However, if we're just talking about regular polynomials like we're doing now, there's only going to be able to be one horizontal asymptote in these cases, in any case we'll see here. And let's talk about why is that. Well, only one of these cases is possible. It's not possible, for example, for a and b to both be true at once for the same function, or for b and c to both be true of the same function, or for a and c to both be true, because these are completely mutually exclusive. These are complete contradictions of one another, and so there is no way, as far as we know, that we can have two different horizontal asymptotes, because these three things are mutually exclusive. Whereas with vertical asymptotes, it is possible to have more than one way to make 0, right? For example, if we have 1 over x minus 3, x plus 2 like this, well, there's more than one x value that I could plug in here to get x equals 0 at the bottom. So there's more than one vertical asymptote. So there can be infinite many vertical asymptotes in some cases. There can be 5 vertical asymptotes, there could be 2, there could be 1, there could be none, there could be any number, but with horizontal asymptotes, we can only have one, because every single graph in this form, either the degree of the denominator is higher, or the degree of the numerator is higher, or they're both the same degree. And in the case that the denominator degree is higher, or that they're the same degree, that means there's one horizontal asymptote. And in the case that the numerator degree is higher, then there's no horizontal asymptote. Okay, so let's talk about oblique asymptotes. So these are asymptotes that are not completely horizontal or completely vertical. These are asymptotes that are somewhat diagonal. They don't have to be on a true diagonal, like they don't have to be, sloping with exactly 1. It could just be any other line that is not completely horizontal and not completely vertical. An oblique asymptote is a slanted line that can have any slope. Well, other than 0, right? If slope is 0, then it's just a horizontal asymptote, and if the slope's undefined, it's just a vertical asymptote. But it can have any other slope. A function f of x has an oblique asymptote if and only if the highest power in the numerator is exactly 1 degree higher than the highest power in the denominator. So, for example, if we have x squared minus 4 over x, here the degree in the numerator is 2, and the degree in the denominator is 1, right? Here the degree in the numerator is 5, and the degree in the denominator is 4, right? And so in that situation, or in both of those situations, the degree of the numerator is exactly 1 higher. So in every case where that is not the case, anytime that that's not the case, we automatically know that we do not have any oblique asymptotes. Okay. Very good. All right, so let's move forward. I have some examples here for us today. This example one says, for the function y equals x plus 3 over x squared plus 4x plus 3, determine all possible asymptotes. Well, let's start with oblique asymptotes because that's easy. Well, is it true that the degree of the numerator is exactly one more than the degree of the denominator? No, it is not true, right? We have degree 1 here and degree 2 here, right? Because here is x squared with little 2, and then x is the same as x to the power 1, right? And so, therefore, we do not have that case. We don't have that situation here. So no oblique asymptotes. Now, what about a horizontal asymptote? Well, it fits into this category here, where the degree of the denominator is higher than the degree of the numerator, so it fits into A. So that means we have a horizontal asymptote at y equals 0. I'm just going to say HA for short. It means horizontal asymptote at y equals 0. And we didn't even have to do any calculations for that because we could just recognize that this fits into category A, and therefore y is equal to 0 is our horizontal asymptote. Now we need to determine the hardest one, which is, are there any vertical asymptotes? So to do that, I'm going to factor the bottom and then figure out if we can cancel anything out or not. So let's do that. So y is equal to x plus 3 over x plus 3 x plus 1. And if you have trouble understanding how did I factor that so quickly, there's videos about factoring quadratics. That's a whole other topic. I won't get into it here, but there are other videos on that to go review if that was a confusing step. Okay, but now that we have it here, we can clearly see we can cancel these out, and this is equal to 1 over x plus 1. So that means we have a whole at x equals to negative 3 because it canceled, and we have a vertical asymptote at x is equal to minus 1 because the x plus 1 does not cancel out with anything on the top. Okay, so therefore, what do we need to do? It didn't say anything about direction, it just said determine all possible asymptotes, and we did that. We determined that the asymptotes, I'll just kind of put a little conclusion here, that the asymptotes are y equals 0 and x equals 2 minus 1. Those are the only asymptotes. Now, there is a hole at x equals to minus 3, but that is not an asymptote. That's a hole, and we established that earlier. And they didn't ask us to talk about the end behavior or, how the asymptotes are being approached. It just asked to determine all the asymptotes, and we did it. Awesome. Let's move on. Okay, let's try this one here. It says, for the function y equals x over x cubed plus 8, determine all possible asymptotes. So first things first, we have a horizontal asymptote at y equals to 0. Now why? Why do we have that? Well, we have that because the degree of the denominator is greater than degree of the numerator, so this falls into the same category as before. And also likewise, we know that can't be any oblique asymptotes because the degree of the numerator is not exactly 1 greater than denominator. In fact, it's not even greater at all, right? This one's degree 1, and this one in the bottom is degree 3 because x cubed demonstrates degree 3. And what about a vertical asymptotes? Are there any vertical asymptotes in this situation? Okay, so now let's talk about, are there any we already went over horizontal. Are there any vertical asymptotes? So we can determine if there are any or not by setting the bottom of the equation, the denominator, to 0. Because remember that vertical asymptotes occur when the bottom is 0. So let's do that. X cubed plus 8 would have to be 0 for there to be a vertical asymptote to occur. That means that x cubed would equal to negative 8, and so that means x is equal to the cube root of negative 8. Now, some of you might be tempted to stop here and say, oh, we have a negative in our root sign, we can't do anything about that. However, this is not a square root sign, this is a cube root sign, so actually there is an answer, there is a real answer here, and it's negative 2, right? Negative 2 cubed is negative 8. Since we're multiplying this negative number 3 times, we actually do get a negative number out of it, which is very, very good. But yeah, there we go. We have a vertical asymptote at x equals 2 minus 2. So in conclusion, what are asymptotes? It's y equals 0 and x equals to minus 2. So I feel like we're kind of getting in the swing of things here of, for a horizontal asymptote to figure out which category it falls into to know where that is. And also for the vertical asymptote, we need to figure out when is the denominator equal to 0, and that will help us. Let's move on to example 3, determine all possible asymptotes here. So keep in mind that x over x, this is the same as 1x over 1x, right? And so the degree is the same, and also the coefficient is the same, right? It's just 1 over 1 are the coefficients. So we have a horizontal asymptote in this case at y is equal to 1. Why is that? It's because in this case it falls into category B, not category A. So we just take the coefficients of that highest degree. That highest degree is only 1. And so those coefficients are also 1. So just don't be confused by coefficients versus degree. The horizontal asymptote is not 1 because the degree is 1 for both. The horizontal asymptote is 1 because that's what the coefficients are. So just keep that in mind. As for vertical asymptote, the vertical asymptote is x equals to 2, right? Because if x was equal to 2, the function would be undefined, and x minus 2 cannot cancel out with anything on the top. There is no way we can cancel x minus 2 out with x plus 3. That isn't right. All right, let's move on to this fourth one here. So this fourth one is the first one that might have an oblique asymptote because the numerator is 1 greater than the denominator. But we're going to save the oblique asymptote for last. Let's find out the horizontal and vertical asymptotes first. So in terms of, let's ask ourselves, which category for horizontal asymptote does this fall into? It falls into category C, right? The numerator degree is higher than the denominator degree, right? By exactly 1. Although that doesn't matter for this, we just need to know that it's higher. So there is no horizontal asymptote, and we can move on. As for vertical asymptote, there is the vertical asymptote at x equals to negative 1. Now, why can't this be a whole? Because if we were to factor the top, we would not also get an x plus 1, and we would need to also get an x plus 1 to cancel this out with for this to be a whole, so therefore it must be an asymptote. Now, what about the oblique asymptote? In this case, the degree of the numerator is exactly 1 degree higher than degree of the denominator, so we need to find the oblique asymptote. And to do that, we need to actually use our long division method we learned in advanced functions in order to figure it out. So how many times does x go into 2x squared? It goes in 2x times. X times 2x is 2x squared. 1 times 2x is 2x. And then we subtract, and we get negative x here, and then 2x minus 2x just gives us 0. Then here we bring down the negative 1. Now, how many times does x plus 1 go into negative x minus 1? Well, negative 1 times, right? Negative 1. This is plus x. My apologies. This is not negative x. So this should actually be plus 1. 1 times 1 times x is x. 1 times 1 is 1. And then we subtract. And then we're going to get negative 2. Okay, so we're going to get negative 2 as our remainder. Now, we don't need to worry about that, though. We can just say our oblique asymptote is still the answer here. The oblique asymptote is y equals 2x plus 1. And remember how I said an oblique asymptote can be a line other than just a horizontal or vertical line. So it might seem weird that the asymptote's a line, but that is correct here. The asymptote in this situation is an actual line that isn't just completely horizontal or completely vertical. All right, well, that's it for today. Next time, we're going to be talking about the horizontal and vertical asymptotes as they pertain to some graphical examples. There will be more on this later, but that is it for now. Bye, everyone.